Hi, good evening, everyone. The aim of today's class is to go ahead and take you through the properties of Marshallian demand curve. So if you remember, we did this as the Marshallian demand curve. So Marshallian demand curve it was a function of income and prices. We saw it for different kind of goods, and then I've also posted some videos about other kind of goods also. So for example, if I talk about Cobb-Douglas, then we saw that for Cobb-Douglas goods, the demand function X star is alpha upon alpha plus beta m by px, and Y star is beta upon alpha plus beta m by py. This is what we saw. Then we saw for complementary goods. We saw that for complementary goods, X star was m upon px plus py. And Y star was also the same because it is a min function. Then we saw for substitute goods that there can be different cases. Then if you go through the other videos, recorded videos, you will see that there I have done for quasi-linear preferences also. And max function. Max is exactly like substitute good. Exactly the same. The only, substitute good. The only difference is that in max function, you cannot consume the two goods together. So for example, let's say wine and milk. I get positive utility from wine, positive utility from milk, but I can't consume them together. So, I will either consume wine or I will consume milk. So in that case, if price of wine is less than price of milk, I will consume wine. If price of wine is greater than price of milk, I will consume milk. And if both prices are equal, so substitute mein to the IC was coinciding with the budget line. So we said that you can consume combinations of the two goods also. Some part of X and some part of Y. Yahan par you can't do that. So you will either consume wine or milk, but not both. You can't consume both because you can't consume these two goods together. That's what is the property of max function, right? So again, here also, because it is just like substitute good, you will either be having the entire demand for wine. So M by PW units of wine, 0 units of milk, or M by PM units of milk, 0 units of wine, or either milk or wine, but not both. Yeah. So this is also a function of income and prices. So in most simple terms, when I go and I talk about the Marshallian demand function, what we see is that Marshallian demand is a function of income and prices. In do cheezon pe, it depends, income and prices. Now, based on these two functions, I am going to go ahead and I'm going to talk about your properties of the Marshallian demand function. So, ye to ho gaya that it depends on income and prices. But based on that, the question in exam is going to be more or less about what properties hold. So we have to go and discuss those. So write down the first property. Definition 1. Before I do any property, a very common thing that comes in exam is called homogeneous function. Homogeneous function. So write down. A function f of x1, x2 till xn is homogeneous. Just give me a second. Let me just put down lines. Okay, so a function is homogeneous function of degree k if f of lambda x1, lambda x2, lambda x3, so on till lambda xn is equal to lambda to the power k f of x1, x2, so on till xn. So if this property holds true, then we say that this function is a homogeneous function. Let me give you an example. Take Cobb-Douglas function. So utility function x to the power alpha, y to the power beta. What I'm going to do is I am going to replace this x by lambda x and this y by lambda y. Har jagah pe each x and each y will get replaced by lambda x's and lambda y's. What is going to happen? Lambda x to the power alpha, lambda y to the power beta. This will be u from lambda x, lambda y. This can be rewritten as lambda to the power alpha, x to the power alpha, lambda to the power beta, x to the power, y to the power beta. This is lambda to the power alpha plus beta, x to the power alpha, y to the power beta. Just think about this. Isn't this part my original utility function? This part. It is now. X to the power alpha, y to the power beta is my original utility function. So I can rewrite this as lambda to the power alpha plus beta u as a function of x and y. This is u of lambda x, comma, lambda y. When I write my utility function like this, I have been able to go ahead and take this lambda to the power alpha plus beta out. This is what the definition is saying. You multiplied each x with lambda. You were able to factor out this lambda. You were able to get back your original function. Then this is a homogeneous function. The question is, what is the degree of homogeneity of this function? So the degree of homogeneity of this function is actually nothing but, we know it, it is alpha plus beta. This is going to be the degree of homogeneity. So if my utility function is u of xy equal to x square y cube, then I know that this is very similar to this Cobb-Douglas function. And for this Cobb-Douglas function, the degree of homogeneity, that is alpha plus beta. So it will be 2 plus 3, which means it will be 5. So the degree of homogeneity of this utility function is going to be 5. Now, the next thing is, let's take one more function. U is equal to min of x, y. And I'm asking the same question. Is this homogeneous? Let's try this. So I will go ahead and instead of x, write lambda x. Instead of y, write lambda y. This will be min of lambda x, lambda y. Now think about this. See, suppose I ask you, give me minimum between 4 and 7. You will simply tell me that the minimum is 4. But supposedly, I go ahead and multiply each of what comes inside by the same factor. So suppose जैसे मैंने दोनों को ही 3 से multiply कर दिया. So minimum of 4 into 3 is 12. 7 into 3 is 7, 14, 21. So minimum of 12, 21. But what is the minimum between 12 and 21? It is simply 12. But can I say that this 12 is nothing but 3 into 4? And 3 is the factor I multiplied it with. ये तो lambda ही था जिससे हमने इसको अंदर multiply किया. So this is nothing but this is lambda into the initial min of 4, 7. This is nothing but 3 into min of 4, 7. So if I just find minimum of 4, 7, which I know is 4, and multiply it by 3, I will get 12. But on the other hand, if I simply find minimum between 12 and 21, matlab first multiply and then find minimum, I get the same answer. Which means lambda can be pulled out of this equation. I can very well say that this is equal to lambda min of x comma y. So this is lambda into the original utility function. Due to this analysis that we did here, that when you multiply first, yahan pe I multiplied first. Yes, Sachin, tell me.
Ma'am, can lambda be negative?
Lambda is usually not negative because we're talking about utility functions and we're talking about production functions. So we scale it upwards. We don't scale it negative. So for economics oriented purpose, lambda cannot be negative. For mathematical purpose, we can take some negative lambda also, but not from economics perspective.
Okay, ma'am.
Okay. So this is the second kind of utility function. So yes, complementary goods are also homogeneous. Now, let's talk about quasi-linear goods. So third part. Here my utility function is, let's say, root x plus y. Again, I will take lambda x comma lambda y. This is going to be lambda x under root plus lambda y. This is going to be root lambda root x plus lambda. Now here is the problem. I can't take lambda common at any cost because this is just multiplied with root lambda. So if at all I go ahead and I want to take something common, I can take root lambda out, but I will not be able to retain my original utility function. I will get a root lambda here. You try it in whatever way possible. You will not be able to segregate it as a factor of two things, lambda and the original utility function. So these quasi-linear preferences, they are non-homogeneous. You cannot make it into a factor of lambda into the original function. This is not possible. Right? So this is the first definition before we go into the properties, which is called homogeneity. Second definition.